Jai Hind everyone. Myself Rupak Kumar. Today we will going to learn a computer network in which we just start the topic, that is what is TCP services. As we know, TCP, that is transmission control protocol, is basically using this protocols only for sending and receiving the data over internet. And then other than this TCP IP, there is a NetBoy, SXPX and all. So today we'll start what is the services provided by this TCP services. Means what is service we taken from this TCP model. So first we start with TCP services. That is what it start with a delivery, means stream delivery services. Second is sending and receiving buffer, TCP segments. This is what we come to know today in today's lectures. So first start with what is stream delivery services. In this we just see that it is the delivery services which allow the sending process to deliver data as a stream of bytes. When it is just sending in a stream of bytes, means a continuous process of sending of the data from sender to receiver. That is what it is like a stream. So it's called a stream delivery service. Means the bytes or a bits is continuous sending the data. Next point is that it receiving the process to obtain a data as a stream of bytes. Means it is that what at sending it sends like a stream, and at receiver it also it's just receiving the data like a stream receivings. So at both the end the data is sending like a streams. Next we can say TCP creates an environment in which the two process, means in that process we have an environment for process stream seems to be connected by a imaginary tube, and that carries the data across the internet. How the data is sending, how this stream is stream of bits or bytes is just flowing in the internet or flowing in the cable or a tube. That tubes is that capable to receiving data, and at sender end tube is just receiving data, sending data, and at receiver end that from that tube the receivers is receive the data as a stream bytes. So this is the stream delivery service provided by TCP transmission control protocol. So this is here we can see this is what the tube, in this tube we can see here the sending process, means at sender ends the data or bits is just sending through this this tube, and this tube is with streams of bits is flowing. This is what in TCP and other receiver ends, this is what they're receiving through this tube only, and that receiver receiving that stream byte. Means the data is from sending process to receiving process flow through these tubes only, and this tube is basically streams of bytes, and that is what the services provided by transmission control protocol while we are using these protocols over internet to sending and receiving the data. Means a movie is streaming, that is what that they are using this service to streams the bytes or bits of data, continuous moving the data. So what is sending and receiving buffers? So if we talk about the buffers, we can say sending and receiving process may not produces and consume the data at same speed. Means if we sending something or if we receiving something, the process may not produces and consume the data. This means at both the end it may be possible the receivers is not capable to receive the at same speed. What is the sender is sending the speed. So this is what is the buffers between these, means sending and receiving process may not produces the produce and consumes the data at same speed. Means they are it seems like here we can see at that end the data is sending with a speeds of 20 bytes per second, per millisecond, and here is a receiver is not able to receive that speed data, because it is capable of receiving only 5 bytes per second. So this is what the buffering of the data. Here we can see the sending and receiving at both the end is not basically same. It may not be same. So that is what need to a buffers from storage. This is what why we need the buffers from storage. Next we can say use two buffers at both ends, sending ends. One buffer is used, as receiver end other buffer is used. So it's used two buffers at sending buffers and receiving buffers for each directions. Means at both the directions we are just using two buffers for sending and receiving data. Why it's so? Because of speed at both the end. Means if we sending data at the speed of 100 kbps per second, but receiver is not able to receive, or receiver may be capable to receive the more than that 100 kbps. So this is why the buffer is used at the both the ends. Next we can say, in one way to implement a buffer is to use a circular array of 1 bytes locations. So this is what the one of the way to implement a buffer, and it is used as to circulate array of 1 bytes per location. So the operations of buffer is divided into two areas, that is what, white, or we can say empty locations, and a colored means filled location. If the location is empty, it is just colored with a white color, and if it is filled location, then we can say it is used some colored, it is used with a many colors. It's not kept blank, or it's not a white. No, so the operations of buffer is divided into two areas, colored buffer or white buffer. Clear? So here we can see how this process is happening. This is what the sending point, and this is the receiver's process, sending process and receiver process, sending ends, sending point and receiving point. At sending point we can see the data is sending, means if we see, this is what the buffer, this is what the buffer, white buffers, means this is what next byte to be accepted. Here we can see what is the white buffer, white for empty location. This is white, white means this is what the empty you can put, or sender can send the data at this white locations. And next, this is the colored locations in a pink color, means next byte to be sent. What the next byte to be sent? This is what kept in this buffer. So this is one of the buffer, blank buffer, and this is the buffer. The data is to be sent, means this data is to be sent next, and this is already sent. है ना, ये डेटा सेंड किया जा चुका है, ये सेंडिंग हो रहा है, and here we can keep the data, है ना. So this data is just sent over a channel, over a pipe, over a tubes, and this just sent to the network, and at receiver ends the next byte to be received, means this blank is empty, so that the data from sender is the received at this point, again then this point, and then it is then colored. Colored means the data is already filled in this, and then receiver can receive from this point. This data is received, then this is received, this is received, so that it can be received. So this is what it is, the scenario of sending and receiving buffer. At sending buffer we have a next byte to accept, means sending TCP, next byte to be accept from this white portion, and in colored portion next byte to be sent, and this byte is already sent, means sending byte, send byte, and blank to data to be accepted. So this is what the sender end buffers, and in this we can see here we have at receiver end also the blank buffer is blank buffer, where we can receive the next data coming from the sender, and then this data is already received by this buffer, and this data is already read. When it read it is blank. जब इसको read कर लेंगे तभी blank हो जाएगा. Again that next byte to be delivered to the receiver. I mean this is delivered, this is delivered. Then it's again blank, and this buffer is moving. This is what the retrieving buffer. This is what the sending buffer. At this sending buffer, data is sending with this process, and at retrieving buffer, data is receiving with this process. So this is what the concept of sending and receiving buffer. Clear? Next is your, what is TCP segment? Means buffering handles the disparity between the producing and consuming speeds. Means data is producing at sender end, and at receiver end it is consumed. So this is what the two different thing, two buffering, that is what handle between this sending and receiving end. So need one more step before sending the data, means group a number of bytes together into a packet called segment. means they just grouping some data in a packets, and that packet is known as segment. Means what is segment? If we can say, it is basically nothing, a group of number or bytes together into a packets, and it's called a segment, and that group is called segment. Next is adds a header to each segment and delivers the segment to the IP layers for transmissions. Means add a header to each segment. At each segment, we just create a segments of data. This is what the segment of data. Here data is filled in this segment, and it is what's saying that group of number of bytes together into a packet called segment, and add a header to each segment to deliver the segment to the IP layer for transmission. So here we can say we can add the header at every segment. This is what the one of the segment, and we just header this header to the that segment. So add a header to each segment and delivers the segments to the IP layers of transmission. So entire process in a we can say entire process basically a transparent to receiving process. So this is what we can say. Here we can see in sending and receiving buffer, when the sending buffer is send the data, they ready to send the data. So in the process of sending data in a tube, they just create a segment. This is what called the segments of data, and every segment is added with this header. Header is added in this segment. Header is added in this segment, and next, like that, this segment is just streaming in the tubes. This is what the segment 1, segment 2, segment 3, and segment is there. Means when the sender sending the data in a tube, it's just create a segment, and in that segment, every segment it have some headers also. ना तो इसमें सारे क्या होते हैं, headers होते हैं. तो tube में they just sending this, and then they just receive at the receiver buffer. All the data is received from these segments, and that put in this buffer, and that is what receive with the this receiving buffer, and they are ready to receive that data, which is sent through segmentation. This is what how that segmentation is sent. This is what it is here. Add a header to each segment and deliver the segments to the IP layers for transmission. Clear? So entire process is in a transport to receive the process. It is clear how this segment is look like. है ना? Sender is sending, thus making a segment, adding some headers, and that segment is n numbers of segment may be there. Na segment 1, 2, and every segment contain a segment, means the data and plus header. Segment, what segment is contained? A data and a header. Next topic is that what is sequence number? Sequence number in a TCP. So assign a sequence number to each segment, and that is being sent. So sequence number for each segment is the number of first byte carried in that segment. What is the sequence number? Actually, this is nothing but it is the sequence number for each segment. हर एक segments में क्या होगा? Is the number of first byte, है ना? जो पहला byte होगा, the first byte is basically in that segment is sequence number. So it is a number assigned number to each segment that is being sent. तो हर एक में एक assigned करेंगे एक number, and that is what to be sent. Clear? Now we can take a example. This question is from UPTU. So imagine a TCP connections is a transforming a files of 6000 byte. So the first byte is number 10010, and what are the sequence number for each segment if the data are sent in a 5 segments, with the first 4 segments carrying 1000 bytes and the last segment carrying 2000 bytes. This question from coming from you can take from the UPTU previous year questions. So we can say the following shows the sequence number for each segment. If we talk about the segment 1, means sequence number is 1001010, means it's a range from 10010 to 11009. Now, this is what the range we kept. Suppose now, so second segment start from this 10 means after 9 there is 10, and that is what 10 to 120009. Like that, every 9 after 9 the 10. So 12010, the segment 3 sequence number must be 1201010, that is range from 12010 to up to 13009. This is what the range of every segment. This is the range of segment 1, range of segment 2, range of segment 3. And after that 9 we have a range from segment 4 is sequence number 13010, range from 13010 to 14009. This is the segments 4 sequence number. Like that we can find the sequence number of this last, because it's a range from 16,000 byte means 10010, and every carrying 2000. So 2000 का difference आ रहा है, that is what 14010 to 16009. So it's a from it's a 2000 है ना. So this is what we can find the sequence numbers from this given data. So this is what the important question. You may understand this, how we can find if the data is given like that. We can just find the range, and that's we can say last segment carrying 2000 byte. That's what you can find this data. Now segments. Segments is the basically what is the unit? So the we can say segment is the unit of a data transfer between the device at sender end and receiver end. This is what the segment. So segment consists of a 20 to 60 byte headers. Means after the data, the header size is basically 20 bytes to 60 bytes. It may vary from 20 to 60 the size of headers, and that following by the data from the application program. So header is basically 20 bytes if there are no option, and up to the 60 bytes if it contains the options. This is what we can find what should be the size of the segments. This is what we can say TCP IP segment format. In segment format, some part is of header and some part is data. So here we define what should be the headers. Headers में क्या क्या होता है ना, क्या होना चाहिए headers में? We can have source port address. What is the source of this data, from where the data is sending? This is what given in this source port address, 16 bits. Next is your destination port address, where is data to be sent, कहाँ भेजना है, that is what from this 16 byte. Next is your sequence number. There must be some numbers of that sequence. That is what next is in a header is that first is source port, destination port, then we have a sequence number. Means which sequence number of this segment, इस segment का sequence number क्या है, that is what given by this sequence number. तो 32 bits के होते हैं. This sequence number is kept as a 32 bits. Then there is a space for acknowledgement number also in a header. Means if the data is received, what should be the acknowledgement size? It must be a 32 bits. Means in this header from starting we have a source port address of 16 bits, destination port address 16 bits, sequence number 32 bits, acknowledgement number 32 bits. Then we have a header length HLEN. HLEN means header length. Header length is basically of 4 bits. That is what reserved 6 bit is reserved. 4 bit header length. In that we have a 6 bit also, that is what reserved header length, and that is what given by URG, ACK, PSK, RST, SYN, FIN. This is what in a header length. Then we have a Windows size, that is what it is also 16 bit Windows size. Checksum, that is for error checking, that is what 16 bits. And then we have a urgent pointers, it is a 16 bits. And next last part is options and padding, which has kept some portion for options and padding. So this is what how this TCP IP segments headers format is. It is a basically header format. This header contains source port, destination port, sequence number, acknowledgement number, header length, then Windows size, and checksum and urgent pointers. This is what the important from this header segments. So in the TCP segments format, we have a source port address 16-bit field, and that defines the port number of application program in the host that is sending the segments. Next is your destination port address 16-bit field, and that defines the port number of application program in the host, and that is receiving the segments. Next is your sequence number 32 bits field, defines the number of assigned to that first byte of the data, and that contains in the segment. And acknowledgement part, that is what this is, the acknowledgement part of this segment. In this acknowledgement part, we can see a 32-bit field, and that defines the byte number, and that are received of that segment is expecting to receive from this other party, and that is what receiving from the receiver, that is what other party. Header length, it is R of 4 bits field, and that indicates the number of 4 bytes words in that TCP headers. Next is your reserved 6-bit field is reserved for a future use, and that there is some bit is reserved, that is what 6-bit for future use only. Control field, this field defines the 6 different control bit or a flags as shown in figure. In this we can see this flags, this is what the flags, this is the flag, reserved flag. And next is your checksum. Checksum is basically this 16 field bit, that 16 field contains the checksum. That calculation of the checksum for a TCP follows the same procedure as the one described for UDP, User Data Program Protocol. In that we describe that. Next is your urgent pointer. This 16-bit field which is valid only if the urgent flag is set. So it is used when the segment contains the urgent data. That is what options. In last option there can be a 40 bytes of the optional informations in the TCP header. This is what the optional information, we can keep it as a 40 bytes. Here we can see what is the control field. In control field we have a URG. That URG means urgent pointer is valid. Next is your ACK, that is your acknowledgement is valid. PSH, that is what we can say request for push. And RST is just reset the connections. SYN basically synchronize a sequence number. FIN basically terminate the connections. This is what control field you can see in this header segment. The all control field is defined. So descriptions for this flag, this is what already described. The value of the urgent pointer means URG. ACK basically the value of the acknowledgement field is valid. PSH push the data. Next RST, that is connection must reset, and SYN means synchronized sequence number during the connections. So last is your FIN, means it is the termination. When we want to terminate the connection, then you use FIN. Here we can take an examples. If we take example from UPTU, we can say that the following is the dump of a TCP header hexadecimal format. Means a TCP header is given in a hexadecimal format. This is what the TCP header given in a hexadecimal format, and we have to find what is the sequence number, what is the destination port number, what is the acknowledgement number, what is the window size. This is what to be find from this. And the data is given, basically it is in a hexadecimal format. Now, this is what the some data from taken from the some dump TCP IP. So in TCP header, if we talk about the sequence number is of 32-bit in the given address. Second block is used for a sequence number, means in that we can see the second block is which is what it is, basically nothing but 00001, and that convert this, we have to convert this hexadecimal number to decimal number. So when we convert this hexadecimal to decimal, we just came to know that it is only 1. So the TCP ID sequence number in this data is basically 1. Second point is that in TCP header destination port number, if you want to find the destination port number, it is of 16 bits, already know. So in the given address, last 4 digit, this is the important point, the last 4 digit in the first block is used for destination port number, which is 0017. In last 4 we can find last 4 is basically 0017, and that we convert this is in hexadecimal. When we convert this hexadecimal number, which is 23, it is 23 only. Next, in TCP header, acknowledgement number, if you want to find the acknowledgement number, it is of 32 bits, we already know. So in this given address block, it is used for acknowledgement number, which is 0000. When we convert this hexadecimal number, basically it is in hexadecimal, we convert it, it is obviously it is 0. Next is your TCP headers window size is of 16 bits. So in this given address, last 4 digit of 4th block is used for window size, and which is of 07FF. We can see in this, it is basically 07FF. This what this denotes, it's basically what should be the window size, and it is of 16 bits. If we convert these hexadecimal number of a decimal number, which is 2047. So when we convert, we must have to remember what should be the sequence number, 32-bit sequence number, and it is basically second block that is used for the sequence number. Next, destination number, it is a last 4 digit. We have to remember this. Next, acknowledgement number. Acknowledgement number, basically it is the 3rd block is used for acknowledgement number. This is what we can see. This is the 3rd block, 1st, 2nd, and 3rd. So we can say this is acknowledgement number, basically 0. Clear? And last is your window size. What should be a window size? Basically, last 4 digit of the 4th block is used for window size. What is last 4 digit of a 4th block? Last 4 digit of 4th block is basically 07FF. So this is what the window size for this. So if we convert these in a decimal, we can find this answer for this. This is what one of the question from AKTU, or we can say at that time it is UPTU. So this is what we can practice these questions to find the sequence number, destination number, acknowledgement number, and window size. Okay, thank you everyone.